Okay, parent functions notes, not assessments. And again, today's notes is literally just this page. Obviously, that's a lot of information, a lot of blanks, but that's why we're going to spend 2 days on basically this page. Flashcards, Kahoots. If you look online, you can find Quizlets and stuff like that for parent functions. And so there's lots of ways to practice this. All right. Initially, it's kind of a matching situation. So here's our 8 equations, and then you look down, there's 8 graphs and a whole bunch of other stuff. So I think some of this you know. So like look at that first graph and look at your equations, and maybe you don't know what all of those equations look like, but I bet you know what that equation is.
X squared.
X squared. So equation is y equals x squared. How about the name of that equation? Either one, quadratic or parabola. I think you'd say it's a quadratic equation, and the graph is a parabola. I think I would accept either one of those as sort of mean the same thing. So yeah, that's a parabola. That's y equals x squared. We know what that looks like. How about the domain? Good. Let's do it in interval notation, negative infinity to infinity. And the range? Yes, y is greater than or equal to 0. If I want to put that in interval notation, though? Yeah. Again, those are the same thing, but usually we want the answer in interval notation, and we want you to be able to recognize interval notation. So I'm going to be using mostly interval notation now. You're right, if you just say y is greater than or equal to 0, it's correct. All right, so that one you probably know. And when it comes to memorizing these, you're probably not going to memorize any domain and range, because if you know the graph, you can figure out the domain and range. So what you'll be memorizing, if you don't already know it, is the picture, the name, and the equation. Because if you know those, you can look at the picture and get the domain and range. So you don't have to memorize those. That's just more like practice each time. Okay, we can maybe check these off as we go. So x squared, quadratic, parabola, we know what that looks like. Hopefully that one's old news. How about that second one? Do you know what that one is?
The other one was y equals the absolute value of x.
Absolute value. Absolute V for value, because it makes a V. That's a silly way to remember it. Let's go overboard with it here and highlight that V. Absolute V for value. So the equation would be the one that has the absolute value bars on it. Y equals absolute value of x. Again, when it comes to memorizing, if there really is memorizing yet, it's those 3 things. Because once you know those, then you can just pick off the domain and range. And why don't we get some popsicle usage in here? I feel like these are straightforward. I can cold call people. Just put them where people can see who's the lucky winners are. Karis, how about the domain for that graph? Parentheses or brackets? Good.
Is this the same range as the one before?
Good. That's a good way to say it. It's the same range as the one before. It starts at 0 and goes up. So we'll bracket 0 to infinity. Okay, number 3. Now we get to some that we may not have seen before. And I would also say be careful, because number 6 looks a lot like number 3. And maybe even before we talk about names, we should say, well, what is the difference between graph 3 and graph 6?
Well, one starts below. Graph 3 goes below the...
Yeah, graph 3 starts below the x-axis. So that means when you're looking at these, you're going to have to be careful. A quick look, you're like, oh, those are the same. And a little closer inspection, you're like, wait a minute, that one goes below, something's going on right there. And that might help you rule out your options. Do you know which of those equations it is? It's okay if not, because you've probably not done this one before. I wonder if it's process elimination, you know which one it is. Anybody got a guess? Number 6 is the square root, so you're close. So while we're there, y equals square root of x, that's number 6. But square root of x never goes negative, right? You'll never get a negative answer out of that, so that can't be graph number 3. Graph number 3 is not 2 to the power of x. Now you're really running out of options here.
X cubed?
It's not x cubed. It's not 1 over x. Again, it's okay. These are new. Log base 2 of x.
Is that the name or the equation?
Oh, that's the equation. Yeah, good call. Thank you. Y equals log base 2 of x. And its name would be logarithmic. Sound fancy. It's a logarithmic equation or a log graph. That might be the hardest one because we're least familiar with logs. It's also hardest because on most of these you could plug in some points and figure it out. Like if you really got stuck, you could plug in x equals 1 and x equals 2 and x equals 3 and like see which graph matched. That's a little bit harder to do with a log graph. Okay, but now that we're looking at the graph, domain and range should be okay, even if you don't really know what the graph is. Hopefully you can look at the picture and come up with the domain and range. I'm kind of stalling here a little bit to give Jackson and Ethan a moment to think. Jackson, how about the domain?
Bracket 0.
Very nice. 0 to infinity. Oh, that's almost not, that is not quite right. Sorry. And it's hard to tell from this picture, but the log graph does not get to 0. So, minor mistake, and really from this graph it's hard to tell. So it's a parentheses 0 to infinity. A better look at that graph, like you could zoom in and zoom in and zoom in, and it would never get there. So it gets closer and closer and closer, and you know, a calculator only has so many pixels, so eventually it just gives up. It's like, well, it's on the axis. You're like, well, it's not, but that's the best the calculator can do. So this is one of those places where you got to be smarter than the calculator and understand what's going on. So yes, the picture looks like it gets to 0, but no, in reality it doesn't. It just gets really close. Ethan, my picture here might help you with your answer for the range. Because it does not stop there like it looks like in this picture. It goes down forever.
Correct me if I'm autistic. It's like negative infinity to infinity. No.
Yes, negative infinity to infinity.
Okay. Yay.
So a more accurate graph would help with that. Logarithmic, as opposed to square root. You know what? Let's go out of order since we saw the square root. Let's do 3 and 6 back to back here. So y equals square root of x, therefore that's the square root function. And again, you're really only memorizing 3 things: picture, name, and equation. And you're really not even memorizing name and equation because usually those are obvious which ones go together. So you're just trying to remember what graph goes with what equation. After that, you can figure everything else out. Liam?
What was the name of it?
Sorry, logarithmic. And rather than writing logarithmic base 2 of x every time, we just shorten that to log. So square root graph, pretty similar. Maybe I need to do the zoom in thing here so that we can get our domain and range correct. Put some names up here so that people can start thinking about their answer. So Rena, how about the domain?
Would it be 0 to infinity with a bracket or 0?
Very nice. 0 to infinity, a bracket on the 0. It starts at 0. You can take the square root of 0 and get 0. So yes, we'll start at 0.
Would it be the same?
It would be the same, Jack, for the range. Because the y values start at 0 and go up to infinity. Okay, so log and square root look pretty similar. You got to be careful about which one goes below the axis. But I think you can keep it straight because you'll never get a negative when you take the square root of something. So you'll never get an answer that's below the x-axis. Right? You take the square root of something, you always get a positive number or 0. Okay, let's see. Back to our list here. We've knocked out 4 of them. Halfway home. Do you know what the graph of number 4 is?
Y by x.
Well, one of you got it right.
1 over x.
Well, the equation is 1 over x. And that would be the reciprocal function. The reciprocal is when you flip a fraction. 1 over x, you flipped the x into the bottom. So we call it the reciprocal function. As x gets bigger, again, you can kind of test this. As x gets really big, like 5 or 10 or 100 or 1,000,000, 1 over 5, 1 over 10, 1 over 1,000,000, that's headed towards 0. So maybe that can help you link the graph with the equation. Warning, the domain and range are kind of tricky for these. Having said that, I have full faith and confidence in Cole and Preston. So Cole, how about the domain? Look left to right. And I'll give you a hint. There's a break in the domain. That's what makes it tricky. So look, how far left does it start then, Cole? Negative infinity. Cole, what does it go up to? So it does end at infinity, but there's a break in there. There's an x value that's not covered. Your friend's trying to help you. 0. There's no x value at 0 there. So we'll go negative infinity to 0. Take a little break. Pick up again at 0. And then head to infinity. That's a really fancy way of saying x can't be 0.
Is it a u or a v?
It's a u.
What does it use to?
Officially, it stands for union. You never really need to know that. You just always use the u to connect the intervals. But it means union. So left to right starts at negative infinity, takes a break or doesn't exist at 0, and then goes out to infinity.
Isn't it the same thing?
Good. It's the same thing, Preston, for the range. It starts at negative infinity, goes to 0, but doesn't exist at 0, and then goes 0 to infinity. That was the reciprocal function. Running out of options here. How about number 5?
2 to the power of
It's x cubed. Y equals x cubed. If you cube, right, it goes really steep, right? 1 cubed is 1, but 2 cubed is all the way up there at 8. So that's one way to help remember it. Also, if you cube a negative number, what happens if you cube negative 1? You get a negative 1. And if you cube negative 2, you get negative 8. So maybe that'll help keep them straight. Name would just be a cubic. And let's pick some volunteers. Oh, Ryan's got his 3-humped camel there. Liam, how about the domain? Very nice. And Ryan, the range? It is the same thing, negative infinity to infinity. Again, cubic is a little steeper than quadratic, and cubic has some negative values because when you cube a negative, you get a negative. Number 6 we already did. That leaves 2 left, but I bet you know what 8 is. So what's number 7? 2 to the x. So that's an exponent, exponential. And there is some stuff to the left of the picture here, because let's do a little table of values. Like this is, if you absolutely get stuck, then you do a table of values and really start trying to match them up. You won't have time to do that on every single one, but if you get down to 1 or 2 and you can't figure out, then do you know what 2 to the negative 1 is?
1/2.
It's 1/2. The negative exponent flips it over. And 2 to the negative 2 is 1/4. And so it gets closer and closer to 0, but it never gets there, which is a helpful hint for domain and range, or one of them. So it does go forever to the left. It gets closer to 0, but never gets there. Those are words that are helpful when we're thinking about domain and range. Cash, how about domain?
Negative infinity to infinity.
Very nice. Negative infinity to infinity. Outline the range.
So 0 to infinity into parentheses.
Good. 0 to infinity, but with the parentheses because it never gets to 0. And the last one would be y equals x. We just say that's a linear function. Well, I think this is the easiest one of the day, but what the heck, we'll let some people get the easy questions. I should never say that, because then what if Carson or Nick get it wrong? They'll feel bad. But I have confidence. Carson, how about the domain?
It's negative infinity.
Yes, sir. And Nick, the range?
Something.
Same thing. Negative infinity to infinity. Okay. It's like good news and bad, right? The good news is that's all there is. The bad news is that's still kind of a lot of information that you've got to start assimilating in your brain, of making those connections of who's who. You don't even have to turn the page, because we're not doing that page. Like, that is it for today. So we have a few minutes left. Good. We'll do a Kahoot here in a minute. But before you close up shop, look at those. Look at each of those and start thinking through names, equations, and graphs. Like, I'm not worried about domain and range, because if you're looking at a picture, I don't think anybody missed the domain and range stuff on those. So I'm not worried about those. Just make sure you can match up. And tomorrow we might do a physical, like, matching game of name, equation, and graph.